Okay, we want to look at the basic equation that drives hydraulic systems. Just as a side note, you may be familiar with the Ohm's law equation. It has a little diagram that looks like this. Volts is current times resistance. V is I times R. So the way this works, I'm looking at the whiteboard controls, and I'm going to try to freeze it so I don't change anything. So voltage is current times resistance. R is V over I. I'm making marks on it. I is V over R. V is I times R. So that's the way that works. I'm still making marks on it. Give me 1 second here. Let me erase the little marks that I made. Okay. So there's a corresponding image that we can use for force, pressure, and area. Force is area times pressure. Area is force divided by pressure. Pressure is force divided by area. Okay, so let's look at a couple of ways to rewrite this. I'm going to just try to keep it all on the same screen here. F equals area times pressure. Okay, so if we're talking about like inches, let's use inches and pounds. Force is equal to square inches times PSI. So for example, just like a little example here, if we have a 2-inch piston, and here's what I'm going to draw it right below it. So here's my piston. Here's the rod coming out of the piston. If I have a 2-inch piston, maybe I have a 3/4 inch rod diameter is 3/4 of an inch here. If I'm putting pressure on the back side of the piston, not the rod side, my force, let's say that I've got 300 psi. So my force, F, will be area times PSI. So the area of a 2-inch diameter piston, there's two equations you can use. Area equals pi times r squared, or area equals pi times diameter squared over 4. Because diameter is twice the radius, right? Or the radius is half of the diameter. So I guess that's a better way of looking at it. R is d over 2. So since R equals d over 2, r squared is d squared over 4. Okay, so that's where this comes from right here. So I like to use this equation because I don't have to divide the diameter by 2 and then do all that math, that extra math. So for this particular problem, F equals area times pressure, PSI. It's going to be pi 3.14159 times 2 squared over 4, which is 4 over 4, which is 1, times the pressure, which is 300. So this is 1 right here. I'm just going to draw 1 through there. So it's 3.14159 times 300. So it's a little more than 900 pounds of force. Let's see if I can do the math in my head here. 3 times 7 is 27. That's a 2. That's 15. That's 17. That's a 4. 12, that's a 4, 9. So it looks like about 942 pounds of force. And you want to check that on your calculator. I don't have one handy, but it looks like about 940 pounds of force. So what that means is if I put 300 psi on this side of the piston, I'll get 942 pounds of force pushing outward on this side, on the rod. Okay, so I could lift something that weighs less than 942 pounds. If I have a 500-pound block, I can lift that block. If it's a 1,000-pound vehicle, I can't lift it. I have to generate more force than the vehicle weighs, or otherwise I can't make it move, right? So it's a real basic example of the equation and how you use it. So from this, you can generate three equations. F equals area times PSI. You can say that area equals pounds of force over pressure, PSI. Or you can say that pressure equals force over area. So probably the more useful of the two might be this first one here, and probably this last one right here. So for example, if I wanted to know, if I needed, like 1,000 pounds of force, and I have 300 psi to work with, I can rearrange this one to get the area. So area, well, it's right here, force over psi. But I'm not really interested in the area, I'm interested in diameter, right? So since from down here, from this equation, let me rewrite this. There's a little bit of basic math here. So d squared over 4 equals force over psi. So if I rearrange this one more time, let me erase my electrical diagram. Don't need that. Try to keep it all kind of moving forward here. So if I'm solving this for d, I can say that d squared equals 4 times F over psi times pi. So pi moves to the bottom, psi stays there, 4 moves to the top. So d, the diameter, would be the square root of 4 times F over pressure times pi, the square root of that. Okay, so for my example, I wanted 1,000 pounds of force. 1,000 times 4 over with 300 psi times pi. And I take the square root of that. And I don't have a calculator handy on me, so you'll have to run the numbers on that. You're probably going to get a diameter that's an odd diameter, like I'm going to guess a number, let's say 2.387, some odd number. What you would do is you would, of course, look for the next larger standard size. So if it's a 2.5 inch diameter, that's what you would use. Technically, you would be able to generate a little more force than you wanted, but that's okay. You can always reduce the pressure to compensate for that if you're really concerned about getting right at 1,000 psi. So this is how you would work this backwards to get a useful result.